So friends, today we will create a car counter. We will create a single class car counter on YouTube live stream. We will count the cars using YouTube live stream. We are not going to use here any pre-recorded video. So after downloading project code, you will get this kind of zip format folder. Right click and then just click on extract all, click on extract. It will extract the project folder. So this is what our project folder. Inside that we have main project folder and along with the Python code. So we will open now our VS code and we will open our project folder inside the VS code. So let me open VS code. So I have opened the VS code. Go to the file, click on open folder and downloads, and this is what the folder. Again we have project folder, and then we, as I mentioned, we want to open the folder. So this is the folder main YT live stream car counting main. Select it, click on select folder. It will open our test.py, which is our Python code. So now first what we want to install the packages. We need our packages. So we will go the terminal and we will simply mention new terminal. It will open the terminal like this way. So first we need opencv-python. So pip3 space install pip3 space install opencv-python, pip3 space opencv-python, okay, -python. So first package pip3 install opencv-python, hit enter. It will install opencv on our Windows machine. Then we need ultralytics package. So pip3 space install ultralytics, hit enter. It will install ultralytics on our Windows machine. Then we need cvzone package. Let me clear the screen and we will go for pip3 space install cvzone. Just hit enter. It will install cvzone. Clear the screen, and as I mentioned, we will use here YouTube live stream. As you can see, this is the live stream link. So we will use the YouTube live stream. So accessing YT live stream, we need with-gear package, with-gear. So pip3 space install with-gear, pip3 space install with-gear, hit enter, and it will install with-gear package, which I have already installed. And then one more package we need for with-gear, which is the YT-DLP. So pip3 install space YT underscore DLP. This is the package YT underscore DLP. Hit enter. It will install YT-DLP. Hit enter. As you can see, it says the requirement is already satisfied. We install YT-DLP package, the YT underscore DLP package. So this is how we need all these packages. We need opencv-python, then we need ultralytics package, then we need cvzone package, then we need vidgear with-gear, and the one more package YT underscore DLP. This is the package which we need. We have done with package installation process. Now friends, we will use YOLO 12s.pt model. By default model, you can use YOLO 8, you can go with YOLO 10, 11, any model you can use here. This is the YT link, YT stream link, which we will use for detection. And then we have our basic object detection. We have here our basic object detection. Result is equal to, we will detect only class 2, the ID means the car. So car class ID is basically 2, so we will only detect here a car. Simple. And this is what basic object detection. This is the basic object detection. So now let me start here a code. We will freeze the frame. We will mention here a 0, so it will freeze our frame. It will stop the while loop, and if I want to start the while loop, I need to press keyboard space button. So it will basically skip the frame manually, but because I want to explain the code, so I have mentioned 0. So as you can see friends, as I mentioned, this is how the code will work. This is how the final result look like. We are detecting the car because we have object detection. Simple. Then if we want to create the counter, we need a tracker. So the tracker which we will use here, which is the by default tracker from the Ultralytics, as you can see, it says the track ID. So track ID is basically we are going to use from the IDS, which is the by default Ultralytics powerful tracker, IDS. So from IDS we will use for loop track ID. So let's just say, because we know here this is the car class, so now we will change, let me make here, we will change the name, the class name along with the track ID. So it will put that unique track ID on the frame. So let me make here escape. So it will stop the code, it will stop the frame, and now again I will run the code. So now as you can see friends, there is a number, there is a, I'm skipping the frame manually, I'm pressing the space button. As you can see, this car we are tracking with this 2 ID. So this 2 ID is assigned for this car, which is the unique track ID. So we are tracking the object, we are detecting the object. We already know that this is the car, we mention here the car class. Now we are tracking the object using Ultralytics by default tracker. This car get the 2. So 2 is basically this car unique ID. Simple. So we done with object detection, we done with the object tracking. Now the main thing is counting. So for counting we will use single line. So how do we draw the line? For that, inside code I have mentioned mouse move function, cv2.event mouse move function. So when you move your mouse cursor on the frame inside Visual Studio Code shell, you will get the XY coordinate. So let's just say if I want to start my point from over here, so I will get the coordinate 314476. So I have mentioned this as a line P1, means the line start point. This is the line start point. So just move the mouse cursor over here, you will get the coordinate inside shell. Inside shell you will get the coordinate, mention this as a line P1. Now the end point, just go over here, you will get the coordinate which is the 566256. As you can see, 565257. So this is how you will get the coordinate for drawing the line, the start point XY coordinate and end point XY coordinate. It is really easy to get the coordinates because we have cv2.event mouse move function. So with the help of this function you will get the frame point, where you want to start the line, where you want to end the line. Simple. So this is how I have draw the line. Then at the end, here it is, as you can see, cv2.line. cv2.line, we will use the cv2.line method, and we mention here line P1 and line P2. This is how we draw the line on the frame. The line color is basically the white and thickness is basically 2. So now we have object detection, we are tracking the object, we have car class, we draw the line. Now we done with 50% already. Now the main thing is what? We have tracker. Now we will save the tracker, means we will save the track ID along with the object current position. So object current position is basically their center point, as you can see, the CX and CY. So if I want to draw, let's just say if I want to draw the center point, here I will mention cv2 dot circle, cv2 dot circle, and we will draw the circle on the frame, and the coordinates which is CX and CY, and then we will mention the radius which is the 4, and the color, let's just say 255 and 00, means we want to mention color as a blue, and -1 for filling the circle. So now just open the frame and press escape. It will stop the code, again run the code. Now there will be a center point for each car because we mention here CX and CY, which is the object center point. As you can see, this car we have here blue color point, which is the center point of the object. Simple. So when this center point cross the line, we can say the car is basically out. When the center point go for this side, we can say car is basically going in. This is how the whole project will work. Now we have line, we have center point. Now for creating counter, we have here a function. As you can see, this is the function which I have mentioned as a counter. So counter is basically the px, py, x1, y1, x2 and y2, and it will return x2 minus x1 multiplied by py minus y1 minus y2 minus y1 multiplied by px minus x1. This is the function. This function will return us this type of result. This type of result returns the positive or negative depending on the side of the line. Simple. Now friends, as I mentioned, we want to save, for counting we want to save detected object track ID and detector object center point, means their current position. So for that we created here hist. Hist is a dictionary. So inside this his dictionary we are saving the track ID along with the cx and cy, the current position of the object, because cx and cy is basically detected object center point. It means this is basically the current position. So his basically the track ID and cx and cy. So now inside our his dictionary we have track ID, each object unique track ID along with their current position, means the cx and cy. Now with the help of this hist we can create the condition. So if the track ID in hist, means because we are saving the track ID inside the hist, so we can create the condition like this way. If the track ID inside this hist dictionary, we need previous cx and previous cy, because we have here current cx and current cy, we need previous cx and previous cy. So if the track ID inside his dictionary, previous cx and previous cy is basically the hist, and inside that we will pass track ID, then we will get the previous cx and previous cy. Now we need here previous side and the current side, of the object. So the previous side is equal to our function, which is the counter, this one, as you can see. So we simply call here the counter function, and inside that we will pass, because previous side we want to mention previous center point. So previous side is equal to counter function, inside that we will mention previous cx and previous cy and the line p1 and the line p2 along with this sign. Why this sign? Because line p1 is basically tuple format, x and y, but here we want to mention both as a 1. For that we will use this sign, this star sign. Simple. So line p1 and line p2, previous cx and previous cy, we will get the previous side of the object, and the current side of object is basically again the counter function. We will mention the current position, which is the cx and cy. Again same way, the line p1 and line p2. This is how we will get the previous side and the current side of the object, using previous cx and previous cy, line p1 and line p2, we will get the previous side, and using current cx and current cy, line p1, line p2, we will get the current side. Now we will use this both side for our condition. So if the previous side multiplied by current side less than 0 and the track ID is in counted, so counted is basically the set, inside that counted we are saving those ID which already counted. Okay, so counted is equal to set. So the condition is like this way: if the previous side multiplied by current side less than 0 and the track ID not in counted, then if the current side less than 0, direction will be in, means the vehicle is going in, and then we will increase in count. Here we mention here in count. So right now the in count is 0, out count is also 0. When the condition match, we will increase the counter. It is really easy. If the current side less than 0, direction will be in, we will increase the in counter. We will change the detected object rectangle color. If the vehicle is going in and else the direction will be out, we will increase the out counter. Again we will change the detected object rectangle color, and then we will mention the counted dot add track ID. The counted dot track ID, we are saving all those track ID inside our counted set. Simple. And then we will get the counter. So cvzone.putTextRect method, we will put the in counter, we will put the out counter. This is what our full code. Now let's just run the code along with the while loop. So I will mention here a 1 and we will run our code. So friends, as you can see, I have started the while loop and this is what our final result. Right now there is no vehicle. Watch, this vehicle is going inside. We will increase the in counter. Watch, this car along with the track ID, this car is going outside, out counter will increase, as you can see. So this is how friends, with the help of YOLO object detection and this code, you can detect the car, also you can track the object, and we will doing all this on our YouTube live stream. I hope you learned something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.